Okay, as you can see here, we've got the first case when an identity is undefined, the denominator is 0. That's the first case. If an identity is in the form a equal to square root of f of x, it is not valid for all values of x. Now, when you've got a square root, the identity will not be valid. So it will not be valid unless we make f of x negative. Okay? When f of x is negative, it means that you can't find, remember, you can't find the square root of a negative number. We all know that the square root of a negative number is undefined. Also, if a denominator is 0, then the fraction becomes undefined. Furthermore, if you are dealing with tan, you need to know that for any question that has got tan, the identity will become undefined if x is equal to 90 plus k times 180, where k is an integer. Okay, so I've got a few examples here. Okay, last time. So we equate the denominator to what? To 0 and determine the values of x. Okay, then for tan, we also have tan x equals 0. Right? So let's determine the general solution for sine x equal to 0. So this one becomes x equal to arc sine of 0 plus k times 360. And you get x equal to. Now, arc sine of 0 will give you 0. So you end up having 0 plus k 360. So it will be k times 360 degrees, where k is an element of z. Okay? Remember here, your reference angle is this one here. If you take out your calculator, I expect you to have your calculator in front of you. Shift sine of 0 is 0. So our reference angle is 0 degrees. Okay? But sine has got two general solutions. Okay? So we have to subtract this reference angle from 180 to get another angle in the second quadrant. So this is the first general solution. The second one will be 180 minus 0, which I won't write here. I'm going to assume that you now know. So 180 minus 0, 0 is the general, so it is the reference angle. Let me just emphasize it, that this is your reference angle. That's your reference angle. Okay? Shift sine of 0 is an angle, and it's equal to 0 degrees. And 0 degrees, first quadrant. Okay? Then we subtract that reference angle from 180 to get the angle in the second quadrant. So 180 minus 0 will give us 180 plus k times 360 degrees, where k is an integer. Okay? So we end up having two general solutions here. This one here and that one. These two. Okay? Right? Any questions? Are you okay? So this is the general solution for tan, the first one. The second one now, it is based on the values of x that make the tan undefined. Not when it's a denominator. The tan itself can be undefined for certain values. Those values are x equal to 90 degrees plus k times 180, where k is an element of z. So we end up having four solutions. Okay? Well, I'm confused. Personally, are you confused of finding the general solution? Yes. Where did the 90 come from? Okay. This comes from your knowledge of the of the graph of tan, which you were taught last in grade 10.
Please go back to the first slide.
Which is that?
You want this, the best number. So, I would have had the most.
Where is your calculator? What's tan 90? Put tan 90 on your calculator. All of you put tan 90 on your calculator. Then put tan 270. Tan 270. Okay. Monge, you are, sorry, Tonya, you are right-handed. Your calculator must go on the right hand side. Okay. Oh, it's very important. If you are right-handed, your calculator must go on the right. If you are left-handed, your calculator must go on the left. Okay. All right. All right. So if you put tan 90, tan 270, tan 450, it will say undefined. Right? That's always. It will never change. That's how it is with tan. So when you get any identity, as long as it has got tan in it, the tan will be undefined for these values. So we want to find the values of x such that the identity is undefined. The tan has got two cases. When it's a denominator, the tan must be equal to 0. So we need the values of x that gives us 0. Like, for example, here, if you put k equal to 1 into 1, x equal to 180, put tan 180, you get what? 0. Which means this denominator here becomes what? Undefined. The denominator also becomes undefined if the tan is undefined. So for tan, there are two cases. The tan itself can be undefined. Also, the tan itself, if it's equal to 0, the whole fraction becomes undefined. Okay? So we've got 4 here. Then let's move on to number 2. So we are done with the question only wants us to find the general solution such that the x values will make the identity invalid. So we are done. Okay? Then number 2. Now, number 2, we have got the tan on the right. That tan can be undefined for these values that I wrote in blue. So this is also a solution because of that tan. But fortunately here, the tan is not a denominator, so we can't say tan x equal to 0 because it's not a denominator. So it's only, the identity is only invalid for this value of x for the tan. Okay? For the left-hand side, the denominator, if it's equal to 0, we need to determine what values will make it equal to 0. Okay? So, on the next page, I'm going to rewrite this denominator and equate it to 0. So that's cos x minus cos x times squared x. Cos x minus cos x times sine squared x. This must be equal to what? To 0. If the identity is going to be invalid. So we need to know what values will make the identity invalid. Then here, my suggestion, use your knowledge of factorization because we've got cos here and cos there, and there's a minus here. So we take out the cos x, then we have 1 minus sine squared x equal to 0. Can you pay attention? Okay? Then we equate each factor to 0. So the first one will be cos x equal to 0 or 1 minus sine squared x equal to 0. This one here, if we take the minus sine squared to the right, you get 1 equal to sine squared x. Then we take square roots. I think I have to show you because I don't want anybody to say, I didn't understand what you wrote. 1 equal to sine squared. Then we take the square root, both sides. You get 1 equal to sine x, which is the same as sine x equal to 1. Okay? So let's find the general solution of this equation, general solution of that equation, plus the one for tan, which is on the right hand side. Okay? So here we have x equal to plus or minus shift cosine of 0 plus k times 360, where k is an integer. Okay? Remember, there's a plus or minus because tan is bothered with the first and the fourth quadrant. Shift cos of 0 will give you 90 degrees. Check on your calculator. What's shift cos of 0? So you end up having plus or minus 90 degrees plus k times 360 degrees, where k is an integer. Okay? Okay. So from there, so I've got the two general solutions for this one. Now I need to move on to those two. Okay? Please be aware that here there's a plus and a minus 1. Okay? So, since there's a plus and a minus 1, if I split that up, I can end up having sine x equal to 1 or sine x equal to minus 1. Okay? Now the sine x equal to 1, this one here becomes x equal to plus going to be equal to x equal to shift sine of 1 plus k times 360 degrees, where k is an integer. Right? Please, this is only for this sine x equal to 1. I still need to deal with the sine x equal to minus 1. Right? Then shift sine of 1 will give you 90 degrees. So you end up having x equal to 90 degrees plus k times 360, where k is an element of integers. Okay? But check this. This 90 plus k times 360, it's also accommodated here. Okay? It's also because I needed to be to know exactly what's the general solution of that. Okay? This is unique for sine and cos. Sometimes you might get, if you've got cos and sine the same equation, you might get the same general solution for both of them. So you've got x equal to plus or minus 90. If I don't write it, how would you know that it's possible? Alright, so x equal to plus or minus 90 degrees plus k times 360, where k is an integer, is also accommodated there. Now check this. This is our reference angle. Remember, sine has got two general solutions. So if we subtract this angle here from 180, 180 minus 90 gives us 90. So there's no need to determine the second general solution because it's equivalent to this. Okay? That's only true when you've got sine x equal to 1. When the ratio is 1, that's when you get the same identity, the same general solution twice. Okay? Then let's deal with that. I'm going to use the blue now. Okay? Now for this one, I am going to say x equal to shift sine of minus 1 plus k times 360, where k is an element of z. What is shift sine of minus 1? Minus 90. So you end up having x equal to minus 90 degrees plus k times 360 degrees, where k is an element of z. Okay? Now, do you see that this 90 and that minus 90, we can combine them and end up having this, right? So which means we can just take this one here as our general solution for both of them. Okay, then we also have the tan. Okay, the tan on the right, this one here. That tan squared x will make the identity undefined if the values of x are like 90, 270, and so on. Because tan is undefined when x is 90, 270, and so on. Okay? So our other answer is going to be x must be equal to 90 degrees plus k times 180 degrees, where k is an integer. Now, just to summarize our solutions, we have got these two plus that. The good thing is that these two, they also accommodate that one and this one here. Let me indicate just to indicate for you. So if you write this and that one, then you have determined all the values of x that will make the identity undefined. Okay, so there are three general solutions. Okay, two sets are equal, so we only take the first set. Okay, which will be plus or minus 90 plus k 360 and 90 plus k times 180. Okay? Okay, fortunately, our denominator on the left is sin x plus cos x. The denominator on the right is sin x plus cos x. So, this identity will be undefined when sin x plus cos x is equal to 0. Okay? Now, to carry on here, you can't factorize. So you take the cos x to the left, to the right, it becomes minus cos x. Okay? We don't have tan in this. Okay? But we are going to create tan from here. We divide both sides by cos x. Once we divide that, we end up having tan x equal to minus 1. We don't have tan, so we don't have to worry about the case when tan is undefined. All we have to do is find the values of x that will make those denominators equal to 0. So, end up having x equal to shift tan of minus 1 plus k times 180, where k is an integer. So x is going to be minus 45. Just verify this for me. Shift tan of minus 1. Okay, so that's your general solution. Okay, if you want to test it, you can put, say, k equal to 0 and put minus 45 here, minus 45 there. Sine minus 45 is minus 1 over root 2. Cos minus 45 is equal to 1 over root 2. So the denominator becomes 0. It means the identity will be undefined. So this is the only solution. Remember, it's a formula. It gives you all the values of x that are undefined. Okay.